The first instruction was to sketch the points 3, 5, and 11, 11. So it's not even really necessary to sketch an X and a Y axis. You can just put a point down here and call it 3, 5. 11 and 11 are bigger respectively than 3 and 5, so the point will be to the right and above 3, 5. So you just go out here someplace and slop down a point and call it 11, 11. Then you have a picture. Now your X and Y scales might not be equal, but that's acceptable. So if you just slop down 2 points like this, call the one to the left 3, 5, the one to the right 11, 11, you'll have followed that instruction. Then you are asked to draw the line segment from one point to the next. And everybody was able to do that rather quickly, so we have a line segment from point to point. And then you're asked to construct a triangle. Well, I don't remember how it was, but basically you were asked to construct a line from the first point in the direction of the x-axis. Actually, I think it said construct a triangle whose legs are parallel to the respective coordinate axes. So if we start here, we can draw a line here parallel to the x-axis. And then from this point, we can draw a line parallel to the y-axis. They intersect down here, giving you a right triangle. And it's probably worth putting the right angle in there, but that's implicit. It's, I think, well understood. So now we have a right triangle from this point to this point. Then I said, I could have just asked, what's the distance between the points using this triangle? And maybe you would have gotten that, and maybe you wouldn't have. So I was a little more specific. I said, can you use the Pythagorean theorem to find the distance between these points? Well, from 3, 5 to 11, 11, we would move in the horizontal direction from here to here. Now, the x-coordinate at 3, 5 is 3, so I did draw a little light x-axis here and a projection to indicate the point 3. And over here, the x-coordinate is 11, so I drew a projection, and I have 11 here. Now, since these two projections are perpendicular to the x-axis, they're parallel to each other, so that this distance is equal to this distance. And that's something you kind of implicitly know, but really, if you're going to think deeply about it, you really want to make sure that this distance is equal to this distance, even though you pretty much know it should be. So that distance from here to here has to be, well, from 3 to 11, the distance is what? 11 minus 3. Of course, you count that on your fingers, 4, 5, 6, 7, 8, 9, 10, 11. But you know that you can get this distance by subtracting this coordinate from this coordinate. So we do 11 minus 3 is 8. Now we know this leg of the triangle. We do a similar thing for the y-coordinates, which are 5 and 11, and we find that this leg is 11 minus 5 equals 6. So what's the hypotenuse going to be? Well, the distance is the length of the hypotenuse, which is going to then be the square root of 8 squared, the square of this side, plus 6 squared, the square of this side. And I shouldn't have to tell you how to write down the Pythagorean theorem. And that is the square root of 100 or 10. So now we know that this side has length 10 and that the distance between these points is 10. We didn't use a formula, okay? And as I said in class, it's ridiculous to use this formula to answer this question. Not saying you shouldn't be aware of this formula, but you're going to forget this formula a long time before you forget this picture. You're going to retain this picture, especially if you use it a dozen or 2 times in solving the problems that have been assigned. So it's very important to draw this picture and do everything in terms of the picture. And then it doesn't hurt a thing, and I would recommend it. Go ahead and identify your x1, x2, y1, and y2, plug into the equation, and see that you get the same thing. And if you don't get the same thing, then you're going to have to either adjust your picture or your use of the equation and the formula. Okay? Now, in an SOL-driven curriculum, I find that almost nobody comes out of high school knowing how to think in terms of this picture. being able to think in terms of this picture is far, far, far more important than being able to memorize and apply this formula without understanding where any of it comes from. And we see another example here when I start asking about the slope. If you know how to draw this picture, and it just consists of 2 points with the coordinates labeled and then the legs parallel to the axes. Okay? If you know how to draw this picture, then you would know how to draw this picture where we go from point x1, y1 to point x2, y2. Having drawn this and knowing that this run here from here to here is going to be x2 minus x1 for the same reason it was 11 minus 3 up here, and that this one is going to be y2 minus y1, this coordinate minus this coordinate, for the same reason it was 11 minus 5 up here, a reason that you will understand if you draw this picture. Then you can write down this formula. The hypotenuse is the square, well, the hypotenuse is the square root of what you get when you square this leg, and add them. So the hypotenuse is this squared. Well, there it is, x minus x1 quantity squared, y2 minus y1 quantity squared, this one, 2 legs squared, square root, you've got the hypotenuse, which is the distance between the 2 points. You don't need to memorize a meaningless formula. You do need to be able to symbolize. And that's a skill that is a little harder to develop. And I'm not going to throw too many stones at the SOL for failing to develop that skill very highly, because it is a skill that takes some time. I think the SOL could have a little bit more of this thing so that a little more of it would be taught, because the SOL is a tail that wags the education dog. But certainly the SOL should require the drawing of this picture and things that you can only get by drawing this picture. And if it doesn't, it's not going to get taught. Teachers are forced to teach this formula to short-term memory so that people can use it without understanding anything that they've done except identifying those coordinates, which is a non-trivial skill, but much less useful and much less, I'm missing a word here, much less persistent. It doesn't persist as long as a picture will, and the ability to use the picture. Again, the ability to symbolize, to go from this picture where we have specific coordinates to think that, okay, I've got to make this one x1, y1 and make this one x2, y2 is a little higher level skill. So deriving this formula is a little higher level skill. One that many people can achieve, but one that you don't want to expect too much of right at the beginning. Okay, well, this picture gives us this formula. Now, there are 2 other questions that are involved here. Okay, the question is, okay, what's the slope of this triangle? Well, nobody could tell me. Okay, so I have a whole class full of intelligent people who've had courses where they should have learned this, who can't tell me what the slope is. Why is that? Well, asking a little bit, I find that, well, there's a formula for the slope, but I forgot it right after the SOL. Haven't used it since, so how should I remember that formula? Well, that's a good question. Okay, you probably shouldn't remember that formula for years and years. If you don't ever use it, it's going to escape you. Okay? And nobody could answer what words come to mind when I say slope, and nobody had any words. And then finally I dropped the hint. Well, they both start with R. One student kind of hesitating and said, oh, rise? And then said, well, okay, rise and run. And it immediately came back to people, but it's not the first thing people think of when they see slope, which means that they are not thinking of what the meaning of the slope is. Okay? They have a formula, but no meaning. And this is what comes out of an SOL-driven curriculum. And I don't fault teachers. Teachers got to get people to circle the right number on an SOL. Okay? That's easier to do on a short-term basis by memorizing a meaningless formula that people can mechanically use rather than having to think about what anything means. Okay, well, so slope is rise divided by run. Here, what do we mean by rise? I'm not sure everybody really still understood what rise means because, again, reliance on a formula bypassing understanding. But I think people were pretty comfortable with the idea, okay, well, this is the rise because it goes up. And this is the run because it goes over. And that would be correct. So we divide the rise 6 by the run 8 and get 3/4. Okay? Well, gee, I don't think I actually wrote down the expression for the slope of this thing. So I'm going to pause and do that. And then I'll stop this video and collect it, and then I'll move on to the other questions that we have. Okay, give me just a second here. Okay, coming back to this picture. What's the rise? What's the run? What, therefore, is the slope? Okay, well, here we have it. Well, the rise is this. That's y2 minus y1. Oh, I did write it down over here. I wrote it down again, won't hurt. And what's the run? It's x2 minus x1. If I'd have just followed my arrow, I would have seen it. Okay? So the rise is y2 minus y1. The run is x2 minus x1. That comes directly from this picture. So the slope is rise over run, y2 minus y1 over x2 minus x1. Okay. A little embarrassed that I missed that, but I'm glad that I didn't leave it out because I was afraid I had. Again, written down over here as well. This is not the starting point. Slope equals y2 minus y1 over x2 minus x1 is not a reasonable starting point for understanding and applying the idea of slope. Rise over run is. It doesn't get done that way because y2 minus y1 over x2 minus x1 is something that's relatively easy to remember in a short term, so one can can circle the right numbers on an SOL test. But it's not the way slope should be understood. This is, of course, my opinion. I'm urging everyone in my class to think in terms of the picture and to understand what I'm saying about the shortcomings of using formulas when you can easily do something by using common sense and simple definitions.